Okay, today we're getting into some three-dimensional figures. We're talking first about polyhedron, okay? So if we have a polyhedron, poly, that prefix means what? Poly. Many, right. Polytheism, many gods. They believe in many gods. Where else do we hear? Polly Pockets. No, that's a different thing. But she has many things, accessories, right? No, that's a different spelling though, double L, right? What's another word that begins with poly?
Polygon?
Well, okay, polygon, which means many
Sides.
sides, many segment sides, right? So a polyhedron actually has many polygons, the very word you just used. So every side is a polygon. So this is an example of a polyhedron. Every side in this case is rectangular. We have a square, which is a rectangle too, right? Here we have another polyhedron. It's a little different than this one because it comes to a point, right? So, but each side is a triangle, or the bottom, what is that shape? 6 sides, hexagon, okay? So these are polyhedron. There's just this big group of figures that have polygons for sides. Triangles, squares, rectangles, hexagons, whatever, okay? We have ways to classify them. One group is known as the prisms. Okay, so we need to figure out how is a prism different from a pyramid. Okay, so let me grab two that are similar in some ways, but not exact. One of these is a prism, and one of these is a pyramid. And so maybe the word prism is tougher because some people use it wrong in the real world. Those things that have mirrors and twist light, they consider them all prisms, right? But one of these is a prism and one is a pyramid. The easier one is probably pyramid. Think of the classic Egyptian pyramid. Which one of these would fall into that category? The left or the right?
Left.
The left, right, because of that vertex, right? So a prism then is this. So how are these two different then? What does a prism have that this doesn't have? Is it spilling?
No.
What does it have? Zach?
There's 2 bases.
2 bases, right? This one only has 1 base. Now, they don't have to be sitting on their bases, but most people love to sit them on their bases, okay? They could be this way, right? In this case, the bases are hexagons, 2 hexagons. What are the shapes of the other sides? Prism. Prism has rectangular sides, see that? But what shape are the pyramid sides? Triangle, that's the difference, okay? So prism has 2 congruent parallel bases with rectangular sides. A pyramid has 1 base. The other sides are triangles. Okay, we have other solids that do not have polygon sides. So here are the examples. These two, and actually, what is this showing up in the right place? Something like this, right? Or the smaller version, right? So these are the 3 additions to 7th grade pre-algebra that you do not cover in 6th grade. You already covered, well actually you covered prisms and you covered these, right? So I'm mistaken. The new additions are pyramids, these, and these when it comes to finding volume and area. Okay, so we're going to talk about those. But let's go back here. So this is called a cylinder. It does not have like flat faces the way polyhedron have. Okay, but it's very closely related to which one of these that we just discussed. The prism or the pyramid?
Prism.
Prism, because these two both have how many bases? 2. The difference is the bases on these are always what shape?
Circles.
Circles. The bases on these can be anything from a triangle to whatever, however many-sided polygon. So these depend on what are the 2 congruent bases. These are always circles. Always, right? The other thing about cylinders is when we can make a cylinder with this shape. What is this shape?
Rectangle.
Rectangle. We can simply take and make a cylinder, right? There you go. So if you work in a soup factory, the labels start like this. They roll the cans over with adhesive and boom, you have Campbell soup. You know, you have your cylinder, okay? The top and bottom, they usually don't have labels there, do they? So they might stamp the date there. So a cylinder has 2 bases that are circles. The side is a rectangle. Okay, so if a cylinder is like a prism, because they both have two bases, then a pyramid is like a cone, because they both have how many bases? One base. But the cone's base is always what shape? Circle. So the formulas for area and volume are the same for these two things, but we can always state the base of a cone. It's always a circle. Always a circle. Can you give me the formula for the area of a circle? A equals pi r squared. Pi r squared. It always is pi r squared. Okay? So that's always what we're going to use when we're talking surface area and even volume. So cones have one base and a vertex opposite that base. Nice pointy part, which if you eat Nestle ice cream cones, they fill that base with chocolate. It's wonderful. They used to leak ice cream, but now they don't. They have a wonderful chocolate plug at the bottom of their cones, right? When we go make these, this week you're going to make all of these figures, three-dimensional figures. So look at this. How much, what you can see on the notes, but do you see that to make a cone, you need how much of a circle? You can see it's a quarter of a circle. That's all you need to make a cone. Okay? Now on these figures that you're going to be cutting out this week, there's these little fringes. They are going to be folded in. The fringe is there so you can glue the figure to the bases and stuff. Okay, so don't cut the fringes off. But we'll talk about that probably tomorrow. Okay? The third and final figure that is not a polyhedron but is an interesting 3D figure is the sphere. So this one actually has formulas on it and so on. A sphere is perfectly what? Round. Perfectly round. So every single point on the sphere is the same distance from a point in the center. So it's as though there's a radius going in all three dimensions, right? So a sphere is like a ball, a perfect basketball, not a football, right? Or maybe a tennis ball or a baseball. We're talking like the earth, okay? So if you were asked to classify solids, you know, in this case, are these both polyhedra? Yes or no? No. Which one is not the polyhedra? The sphere. Okay, now this is a polyhedron because it has polygons for sides. Okay, so we can divide up the polyhedron into these two categories. And so this category is the these are prisms. Let's show a few prisms. Two bases. Here we go, two bases, triangular bases, but still a prism. See the rectangular sides? Okay. And here we have two bases. And still triangular bases, but rectangular sides. So we can classify prisms versus pyramids. Here's a pyramid. Here's a pyramid. Think of the classic Egyptian pyramid, a vertex on the end. Okay? And then we have that other group, cones, cylinders, and spheres, that have the circle in common, right? I know the sphere doesn't look circular, but when we rip it apart, here I have one ripped apart. Here was a little kid's baseball. It started to come undone. One of my students years ago. And I said, ooh, can I have that? Because what shape do these almost look like? It looks like I almost have four what?
Circles.
Four circles. And guess what the area of a sphere equals?
Two circles.
Four circles. 4 pi r squared.
That's so weird.
It's easy, isn't it? If you think about a baseball ripped open like that, it's like 4 circles. Okay? Parts of a polyhedron. These are again just some definitions that we all need to understand so we can talk about these figures as we do more interesting things with them. Polyhedron have edges. So here we go, we got edges. What makes up an edge? Like here I have this edge here. Bailey, what would make up this edge? What causes it to be there, that edge? Well, what's coming together to make that edge?
Triangle.
Triangle, just one triangle?
3 triangles.
Is it 3? Or is it just 2, isn't it? 2. Okay, so an edge is really made by 2 faces coming together, making that edge, right? 2 faces. Okay? Line segments where the faces are meeting. Now, if we have 3 edges meeting, 1, 2, 3, we have a vertex. Okay? We could even have more than 3 edges meeting, like in this hexagonal pyramid. There are 6 edges, 6, actually more than 6. 1, 2, 3, no, there's 6. 6 edges meeting. And so we have a very sharp and dangerous vertex on the hexagonal prism. Okay? So vertices are in the real world called corners, right? And they are where the edges meet. One final word for today, and the word is diagonal. And it is a little bit new, maybe for 7th grade. A diagonal. So if I take my rectangular prism here, to form a diagonal, I mean, you know how to play tic-tac-toe, right? You know a diagonal. So why is this vertex to this vertex not a diagonal? Or if I tell you right now that that's a diagonal of this polygon, okay? But I want a diagonal for the whole polyhedron. And so this is not considered a diagonal of the whole polyhedron. So where would the diagonal be if I started from this vertex here, the upper left? Where would it go to be a real diagonal of a polyhedron? Michael? Like down to here? Cross and down, that would be more of an L shape, not a diagonal. I just need one diagonal. Where would it be? Right.
From the corner to the bottom.
Down here? That's still not a diagonal of the polyhedron. It would be a diagonal of this rectangle face here, but not the polyhedron. Jimena?
John, like where the square, the base is?
Down to here?
No.
This way? No, it's still not a diagonal. That would be a diagonal of this face, but not the polyhedron. We need a diagonal for the whole polyhedron. Jeremy?
So the bottom right corner, and then go to the top left corner on the other side.
On the other side. Okay, so let me use this corner that we were just starting with. Here's this vertex. We would have to go through the figure. A diagonal goes through the center, through all that rice, down to the bottom, back right corner. Upper left, front corner, bottom back right corner, right through it. It kind of reminds me of when they make gyros, but that's usually just straight on a stick and it spins. So if it was diagonal through, you have the idea. Okay? Don't see too many of these in the real world. A line segment between 2 vertices not on the same face. Never on the same face. You sometimes see these when you're driving across the country and there's like a drive-through, like an A&W root beer, but I think it's more Foster's Freeze, where they have a milkshake, like kind of tilted. They have like a milkshake container tilted and they have a stick rotating it, but it's like tilted. So it's like a diagonal of that figure, okay? So remember, if it's a diagonal of a polyhedron, it's going through it, okay? Because it's 3D we're talking here, not just 2 dimensions. Okay, you have all the words you need to know to do this. So have fun.